Okay, so 3.2 polynomial functions and their graphs. So a polynomial function of the degree n is a function of the form p of x equals this large entire equation. We're going to break it down. Anytime you have numbers where it's a of 0, a of 1, a of 2, a of 3, those are what we call our coefficients. The next one is if we have a of 0, that is just our constant term, very important. It's normally at the end of our equation. The number a of n is the coefficient with the highest degree. It's called our leading coefficient. And then that whole portion of a n x to the n power is just our leading term. So if you look here below, we have our leading coefficient, which is the value of 3. Our leading term is 3x to the 5th. That's the very first term we see. And then our leading degree is our 5. The coefficients are just the numbers that are in front of those variables. And then our constant term is at the end, which is -6. Notice here we have some examples of what are classified as being not being polynomial functions, which are here in yellow. They have a break, a hole, or some type of a corner. If we have an actual polynomial function, notice how smooth it is, how continuous it is. There's no jumps, there's no gaps in between, no breaks. So these are just the difference between these. Here's some information about the graphs of basic polynomial functions. We also like to identify these as your parent functions. Very, very important to know these parent functions. Notice that you have y equals x that forms a line. Y equals x squared forms our parabola. Y equals x to the third kind of forms this little S, kind of looks like a snake. X to the fourth is a parabola, however, at its vertex, it's a little bit wider, so it crosses over the x-axis a little longer. And then our x to the fifth power, very similar to x third to the third. However, again, at that x value, it kind of lingers across that x-axis a little longer. Graphs of polynomial functions, and we're going to talk about their end behaviors. This is some information from that foldable that I gave you, graphing shapes and end behaviors for that chart. So end behaviors of polynomials, they have this same form of p of x. It's determined by the degree n and the sign of the leading coefficient a of n. So this is very important of how we determine the end behaviors. It's indicated here in this image. So notice here you have, if p has an odd degree, notice how the odd degree shows that there is a up and a down. However, for the down portion, facing downwards, we start on the negative side of x, and then we go up towards the positive side of x. So if you read here, it says the leading coefficient is positive. That means y goes to negative infinity as x goes to negative infinity. Then if we look up at the top here, it says y goes to infinity as x also goes to infinity. So this is if your leading coefficient is positive and your p-value, p has an odd degree. Then when we look at the next one, notice how it's up first and then it's down. It tells us that when we have a leading coefficient that's negative, being that the p has an odd degree, that means that y goes to infinity as x goes to negative infinity. And the same if it's going downwards, y goes to negative infinity as x goes to infinity. When I look here where p has an even degree, notice how your graphs are both facing upwards. That means your leading coefficient is a positive. So that means that y as it goes to infinity as x goes to negative infinity, and then y as it goes to infinity as x goes to infinity. So both x and y are positive. The last one is, notice how they're all facing downward. That means the leading coefficient is a negative. This is dealing with even degrees. So x goes to negative infinity as y goes to negative infinity as x also goes to negative infinity. Whereas on the right side, y goes to negative infinity as x goes to positive infinity. So just understanding your degrees. So if you have an odd degree, that means that you're going to have a graph that look like this, and you just will need to know whether it starts positive or negative. And if you have a even degree, depending on if your leading coefficient is positive or negative, will tell you which direction your graph should end. So we're going to do an example. It says describe the end behavior of the polynomial function. So the first thing I'm going to look at is what is my leading coefficient sign? Well, for this one, the leading coefficient sign is a negative, which also, next I'm going to look at what's going on with the degree. So the degree of this polynomial here is an odd degree. 5 is classified as being odd. So this tells me that my graph will go something like this on one end, and on the other end, it'll do something like this. So when writing this information out, I know for y as it goes to negative infinity, as x goes to positive infinity. It's almost like what happens if you draw a graph here, your table. Then I look at as y goes to infinity, as x goes to negative infinity. So let's look at B. Again, first we're going to start off with leading coefficient. It's going to be a positive. Now when we look at the degree of this polynomial, tells us that it's going to be an even number, and that is 4. That means our graph is going to move upward and upward. If you were to draw some type of equation. So I want to read this as y goes to infinity, as x goes to negative infinity. It also means y as it goes to infinity, as x goes to infinity. Then let's look at the last one, which is c. So with this one here, I know maybe FOIL transfer, and I can combine these x's. Well, if I do that, it gives me the fact that I have x the term of whatever may happen. So I know the sign of this, or the leading coefficient sign, is going to be a positive. And I also know the degree, and my degree is going to be odd. So that's based on my rules. I'm going to have something that does this. On the other side, I have something that does this. So I can list it out by saying as y goes to negative infinity, as x goes to negative infinity, or as y goes to positive infinity, as x goes to positive infinity. Okay, so this one we're going to look at using zeros to graph polynomials. So if C is a zero of P of a multiplicity M, then the shape of the graph of P near C is as follows. So the multiplicity of C, if M is an odd number, then that means that M is going to have to be greater than 1. If M is an even number, that means M is going to have to be greater than or equal to 1. So the shape of the graph of P near the x-intercept C will have this type of form. So it's just basically saying everything that we've talked about, contingent upon what C may actually be. It'll tell you exactly where your value is going to cross the x-axis, whether it's going to be x cubed or negative x cubed or positive x squared or negative x squared. Okay, so here's an example of how we're going to apply that rule. It says sketch the graph of the polynomial function. I listed out here all the images of the functions. So we have p of x equals x times x minus 3 times x plus 3. First thing I want to look at is what's going on with my leading coefficient and my degree. So notice here you have a set of x's. So our highest degree is going to be x cubed, so it's going to be an odd, and our leading coefficient is going to be positive. And sign is going to be positive. So that's first by listing that out. Then I want to take every single part of these and set them equal to 0. So if I take x equal to 0, I know x equals 0 gives me some type of a linear format, makes a line. Then if I take x minus 3 and set that equal to 0, I get x equals positive 3. Well, I also know that this is a linear image. And then if I take x plus 2 and set that equal to 0, I get x equals negative 2. And that's also linear. So I know at some point I'm going to kind of have more of a line type image. Well, I talked about in the last couple of slides what the image looks like because it is a positive, but the degree is odd, which means I have something that goes down here and then something that's above that goes up like this. So that's just the shape of everything. First thing I'm going to do is go ahead and plot my linear points. So at x equals 0, x equals positive 3, and x equals negative 2. So I also know, remember, this is the shape that we're trying to go for. If these are linear images, I'm going to go ahead and look at how linear lines form. Linear lines are straight, so you want to be able to see some type of a straight image that occurs. So looking at this, I'm going to start from down here because that's where my image says start. And I'm going to go up, and because it kind of forms a line like linear, I'm going to go ahead and come down a little bit to 0. I'm going to kind of come back down again and go back up because that's how I should end. So this is a rough sketch of how this graph will look. And if you notice here, we kind of have some straight edges there, kind of have a straight line going there, and kind of a straight line going here. Again, they're rough sketches even though they do curve. But this would be a sketch of the graph of this polynomial. Okay, let's look at this one. Sketching the graph again, x cubed plus 2x squared minus 8x. First thing I want to go ahead and list out. I want to list out what is its leading coefficient sign. It's going to be positive. And then I also want to go ahead and list out what its degree is going to be. So the highest degree I have here is going to be an odd degree. So I know that my graph is going to go down first and then up. From here, I want to look at, can I factor out something? Absolutely. I can factor out a x. I get p of x equals x times x squared plus 2x minus 8. Now I can take each term and set them equal to 0. So I have x equals 0, and then I have x squared plus 2x minus 8 equals 0. From this, I'm going to go ahead and factor. So I still get x equals 0. That doesn't change. But for here, I get x plus 4 and x minus 2. I get x minus 2 equals 0. Set these two equal to 0. That tells me x equals negative 4 for one of them. And then I set this other one equal to 0. And that tells me that x equals negative 2. Notice these are all linear. So they're going to have some sort of a straight line image. So I'm going to go ahead and plot these points on my graph. At 0, x is at negative 4, and x is at negative 2. Or sorry, x should be at positive 2 here. So because x is at 2, kind of gives this graph image of starting down, coming up, going down, and coming back up. This again is your rough sketch of what your graph would look like. Notice how there's kind of like a straight line, kind of another straight line, another straight line. Don't judge my lines. But they're partially straight, kind of gives you off the linear equation. I'm going to start recording on the next lesson, or start on the next example, starting with example 4.